Right, this is the beginning of chapter 8. So chapter 7 is what we were working on before all this kind of went crazy. And so we had that quiz, so I'm just going to have that be the end of chapter 7, start on chapter 8, which is talking about sampling variability and sampling distributions. And today we're going to be looking at this goal of 8.1 is our first goal, and it is I can differentiate between population characteristics and a statistic. So knowing the difference between those two things and know general properties of sampling distributions of a sample mean. So we've kind of talked about mean, and we've talked about standard deviation. So those things you're going to see here, but you're going to see a sample mean and standard deviation compared to a population, because there's sometimes when you can't take a whole population. So here is the first thing that we're going to talk about. Suppose we're interested in finding the true mean. So this is your true mean fat content of a quarter-pound hamburger marketed by a national fast food chain. To learn something about the true mean, so again, whenever we see this is our true mean, we could obtain a sample of 50 burgers and determine the fat content of each one. So the sample mean would be written as X with a line over it. So this means the sample mean. Would the sample mean be a good estimate of the true mean? And how close is the sample mean to the true mean? And it kind of just depends on, one, if we have really good sample, we have a pretty good size there, and the larger your sample gets, remember that's how closer we get to the true mean. And would other samples of n equals 50, so if I take 50 somewhere else, would that have the same sample mean? And they should be pretty close. They might not be really close, but since we're dealing with such a large number, they would be pretty close. So we will example to kind of get into this and really cover this. We're going to examine sampling distribution, and which is your long run behavior of a sample statistic. So looking at the sampling distribution. Remember, the sample mean is a statistic. So when I'm just taking from a group instead of from a large, that is your statistic. So part of your homework is determining between a population and a statistic. And statistics is always when we take from the sample, and population is always when we look at all. So a statistic is a number that can be computed from a sample data. So I'm just looking at a sample data, and any number that I can get from that and compute is called a statistic. Some statistics we will use include the sample mean. So again, that means sample mean whenever I see that X with a line over it. And S is standard deviation. The population standard deviation is this Greek symbol like this. This would be your population standard deviation. And this symbol, this little hat should be kind of over the P, is your sample proportion. And that will probably work on a little bit later. So those are the things that we're going to be some of the statistics that we'll be looking at. The observed value of the statistic depends on the particular sample selected from the population, and it will vary from sample to sample. And this varying is called our sample variability whenever it changes from sample to sample. And the closer that we can get those samples to be the same, then we know we have a good group of data. So here is a fish pond at Wolf City College. So we have 20 fish. This is our population, 20 fish in the pond. The length of the fish in inches are given below. So we have this, every single one in there. If we randomly catch a sample of 3 fish from this pond and measure their length, what would the mean length of the sample be? So say we caught fish with length 6.3, 2.2, 13.3. So how we're finding this sample mean is we're taking 6.3 plus 2.2 plus 13.3. And totaling that up, 21.8, and dividing by 3. So when you have to compute that, that's how we're getting this 7.2666 repeating, so we round to 7.27. That is a statistic. That's just looking at a sample, so that's why that's a statistic. We catch 2 more samples and look at the sample mean. So say here's another set of 3. Again, we'd add those all up, divide by 3, and we'd get the 6.23. And do another one, we would get a sample mean of 10.87 if we caught these 3. So you can see that there's kind of a range in our statistics. So then if we took and found the true mean of this population, which is 8, that means I add all of these up and divide by 20, I would get 8. Notice the sample means are closer, some are close, and some are further away than the actual mean. And that's kind of the problem with statistics, is that kind of depends on where you're at. This one is really close, but this one is a little bit further away. That is just an example of sample variability, where as the mean changes from sample to sample. So if we continue to look at this data, there's 1,140 different possible ways I could take a group of 3. If we catch all of these different samples and calculate the mean, we would have a distribution of all our sample means. And this would be called a sampling distribution of X. This should be of sample means. So the sampling distribution, again, this line is kind of going crazy here, sorry. The distribution that would be formed by considering the value, the sample distribution of the sample mean is the distribution that is formed by considering the value of a sample statistics for every possible different sample of a given size. So that would be taking taking a sample out of the whole population and looking at every possible one. And this is called the sample mean of this. In this case, the sample statistic is the sample mean of X. So if we looked at only 5 fish, kind of bring it down a little bit smaller, we'll keep these small so that we can find all the possible sample means, because we cannot possibly do 1,140 different ones. What is the mean and standard deviation of this population? So if I look at here, again, this means that it's the population. So if I find the mean, I would take 6.6 plus 11.7 plus 8.9 plus 2.2 plus 9.8, and I would divide that by 5. And that's how I would get this 7.84. And the standard deviation, we talked about that, is, remember, we looked at that last chapter, is where you take 6.6 minus 7.84, square that, plus 11.7 minus 7.84, and square that. We're not going to do these all by hand and so forth. And then you would take the square root of those, the sum, and that's how you would get this standard deviation. And that, again, is the standard deviation of the population. I'm not going to have you compute that. I will have you in your homework compute this mean, so make sure you know how to do that. So here's our standard deviation. So if we find all the samples of 2 that we could possibly be, it would look something like this. And here is all of my sampling means that I would get with every population. And again, I'm not going to make you do that. I just want to kind of show you an example here. And this is your sampling distribution of X for our sample size of 2. And the mean of this standard deviation, you'll notice, is also 7.4. So these two means, the mean of the population and the mean of all the sampling distribution means, is the same. But our standard deviation is smaller. So if we look at that, when we look at how they compare to the actual population, that the values are always the same for the sample mean distribution, but it is as we get our groups up, this distribution is getting smaller. So what we notice is the means of the sampling distribution equals the means of the population. And you should also notice that as the sample size increases, so 3, all the possibilities of 3s and so forth, the standard deviation of the sampling distribution decreases. So these are the two things that we notice. All right, so that is our first lesson. Hopefully this online thing isn't stressing you out too much. Again, if you have any concerns or anything, let me know. But click then on the assignment on this and complete that. And I kind of tell you where you can also find that in your book. It's 8.1, 8.2, 8.3, and 8.4, I think A and B, if you want to know where it is in the book, or what questions that we have. All right. Hope you're having a good day. I will talk to you later. Bye.